Okay, so now we're going to add or subtract radicals, and you can only add or subtract radicals if they are alike. So in this first one, you have the square root of 5 and the square root of 7, and those are not alike, so you can't add them. They have to be exactly alike with the same index and the same radicand. In this next one, you have 5 square roots of 3 and 9 square roots of 3, and those are alike. And here's how you're going to think about them. I have 5 square roots of 3, and I have 9 more square roots of 3. So basically you're saying, how many square roots of 3 do I have? And it's kind of like when we add variables in algebra. All you're going to do is keep the radical term and you're going to add the coefficients. So 5 plus 9 would be 14. Notice that the 3 doesn't change at all. That's kind of your base. And all you do is add or subtract the coefficients. Okay, in this example here, at first you think I've played a trick on you. I just told you on the previous slide that you can't add or subtract radicals unless they are alike. And then I give you 2 that aren't alike. So that means we've got to come to the side and do some work. Hey, 27 is not a perfect square, but it contains a number that is a perfect square because it contains the number 9. Now earlier we learned that we could simplify this. The square root of 9 would be 3, and since the square root of 9 is a whole number, it comes out. So this 3 right here comes out. So that gives me a 15 on the outside and a 3 left underneath. Okay, again, you'll say, well, how did that 3 come out? So the square root of 9 was the whole number 3, and that whole number 3 pulls out, and when it gets outside, you're going to times it. Your other one was the square root of 12, and we've talked about that one earlier. That's the square root of 4 times the square root of 3. Well, the square root of 4 would be 2 on the outside. And once I get to this point, I have like terms. So I've got a square root of 3 here, and I've got 15 square roots of 3, and I have 2 square roots of 3. So if I put those together, that gives me 17 square roots of 3. Okay, so let's try our next one. If you want to pause the video and work ahead and see if you get it, that's great too. Okay, so 7 on the square root of 18. The square number that goes into 18 is 9. Okay, the square root of 9 is 3. So 3 comes out. And that gives me a 21 outside and a 2 left underneath. Okay, there's my minus. I'm just going to bring it down. And then I have 5 on the square root of 8. Well, 8 is not a perfect square, but it contains a perfect square of 4. So I could break this down into 4 times 2. Okay, the square root of 4 would be 2 on the outside. So this would give me 10 on the outside. That would give me 10 on the outside and 2 underneath. Now I have like terms. They're both square roots of 2, so I'm going to keep the square root of 2. So I've got 21 square roots of 2, and I'm going to take away 10 square roots of 2. So 21 minus 10 would give me 11 square roots of 2. And that's how that one would look. See how much else I've got. All right, this one is the hardest one of the section. I think it's on your quiz and your homework, but it's not on the final, so that's a plus. Rationalize the denominator is a big fancy word that means get the radical out. And denominator means bottom. So what you're going to do here is get the radical out of the bottom. Now the way that you're going to do that is you're going to multiply this expression here by something called its conjugate pair. Now here's what a conjugate pair looks like. You're going to keep the same terms. Keep the 4 and keep the square root of 5. Keep those same two terms. But you're going to multiply by the opposite sign because you want it to cancel out. So you see how you have a plus in the first one? You're going to pick the opposite sign. Okay, now if you multiply by 4 minus the square root of 5 on the bottom, you have to multiply by 4 minus the square root of 5 on the top. Sorry, I'm trying to make the computer write it in a normal color, but it just won't do it. All right, there we go. So what we're going to do is we're going to multiply on the top like this. So I have 8 times 4, which is 32. And when I multiply by the radical, I have a negative and an 8 outside the radical and a 5 underneath. Now on the bottom we're going to FOIL. So when we FOIL, we're going to say 4 times 4, so that's 16. Here's my outside one here. So that's a negative outside and a 4 outside and a 5 underneath. Here's my middle. So that's a positive and a 4 and a 5 underneath. And here's my last. So when I multiply this last, I have a positive times a negative, which is a negative. And 5 times 5 underneath would be 25 underneath. Okay, so the top one is 30. Okay, the top one is 32 minus 8 on the square root of 5. Okay, and that's it for the top. On the bottom, a negative 4 square roots of 5 and a positive 4 square roots of 5 cancel out. So that leaves me with a 16. And over here, the square root of 25 is 5, so this leaves me with a minus 5. So 16 minus 5 would be 11. Now remember, my goal for this one was to get the radical out of the bottom, and I've officially eliminated the radical from the bottom.